Our first presenter is Iggy Tan, Managing Director of Altech Batteries. Altech Batteries is commercialising a 100 megawatt an hour solid state sodium chloride battery production facility and is also at the cutting edge of developing battery materials for a lithium-ion battery future by successfully incorporating silicon in graphite anodes to produce higher energy density batteries. Iggy, over to you.
Well, thank you for having me, David. So most people will be wondering, what is the future of grid storage batteries? Well, before I start that, I want to talk about where the lithium-ion batteries are heading. They're heading to solid-state technology, and I'm sure you've heard of solid-state technology. I just want to explain what that is because a lot of people don't understand it. So in a normal lithium-ion battery, you've got a cathode and the anode, and there's a liquid electrolyte in between that, which has got lithium, but it's actually very flammable. What the industry is heading to is solid-state technology, where they're removing the liquid electrolyte and they're replacing it with a ceramic piece. And the ceramic is a solid state, which allows the lithium to go back and forth without using that liquid electrolyte. So some of the challenges of the lithium-ion battery is obviously fire. So next, well, there are fire and explosion issues. A lot of people don't realize that lithium-ion batteries only operate in a very narrow temperature range, down 15 degrees to 35 degrees. In fact, when you have your lithium-ion battery in the very cold, your battery slows down to about 70%. Also, we understand there's a limited life of these batteries because every time you charge and discharge a battery, lithium ions degrade. So generally 8 to 10 years in the bigger type batteries. The other concern is critical metals. There are price rises in critical metals in these batteries, and that is also a concern. So let's talk a bit about that. Lithium price has risen fivefold in the last 2 years, and that's causing some concern to the lithium battery sector. Cobalt supply, which is a key ingredient to some of these batteries, come from the DRC, and there's some ethical concerns about child labor issues and so on. 90% of graphite comes from China, so the industry is concerned about a geopolitical risk. Copper is an issue. There is a copper crunch coming. There is a study that shows there's not enough copper mines being built or developed to even meet the EV demand, let alone the grid storage demand, and obviously also materials like manganese. So the next slide. So is there a battery that is actually fireproof, operates at a large temperature range, maybe beyond 15-year life, that doesn't contain any lithium, doesn't contain any cobalt, doesn't contain any graphite, copper, or even manganese? Is there such a battery that's possible? Well, introducing you to the Serenergy battery. Essentially, this is a sodium chloride battery or salt battery with nickel metal powder. So that's what they look like. The technology was developed by the Fraunhofer Institute in Germany. They spent nearly 35 million euros in development over 8 years. And we have a joint venture to develop this technology. So it is actually a sodium chloride battery and solid state. It doesn't have that liquid electrolyte. So it uses a ceramic piece. So therefore it's fireproof because there's no volatile, flammable electrolyte in the battery. The temperature range it operates down to minus 40 degrees and up to 60 degrees. So you can plop this battery in the snow or in the deserts, and it'll operate without any cooling fans and so on. Because we use sodium is a very reactive material like lithium. It doesn't degrade every time you charge and discharge the battery. So the life of the battery should be beyond 15 years. We don't use any lithium, as I mentioned. We use sodium chloride. We don't have any copper in the chemistry, so there's no copper requirements, cobalt requirements. And there is also no anode of the battery. It's actually a forming anodes. So we don't have any graphite or copper. So let me show you the technology and how this battery operates. So essentially you have a ceramic tube, and in the ceramic tube, there is a positive probe. We fill the ceramic tube with sodium chloride and aluminium powder, and there is a medium of sodium alumina medium in it. The ceramic tube, as you can see in the picture there, would sit in a metal canister, which acts as the negative part of the battery. So you've got the positive probe in the middle. The cylinder is the negative part. As you can see a picture here of the ceramic fitting into this. This battery itself, the way it operates, when you charge the battery, the sodium ions migrate through the ceramic sector and builds an anode. So it's a sodium anode that's being formed. And when you discharge the battery, so the nickel's there actually to grab the chloride and allow the sodium to migrate. So if you take a cross section of the battery, you can see the molten sodium being formed. So the unique part of the battery, it's a self-forming anode and a self-discharging anode in the battery. Very unique technology. Here you can see the battery discharging. The sodium ions are now migrating it back, grabbing the chloride and becoming salt again. So very interesting technology here. Next slide. So if you compare the battery, it's a very similar energy density to the lithium iron phosphate battery. It's got a very similar energy conversion, but of course the cycle life is nearly double, much safer because we don't have fire issues. And I mentioned it operates in a very large temperature range. The main point in this slide is the maintenance costs. It actually has virtually zero maintenance costs. So in a LFP battery like the Tesla Megapack, there's something like 240 cooling fans trying to keep the battery cool. In our battery, it actually looks after the temperature itself, because when you charge the battery, it is an endothermic reaction. And when you discharge the battery, it's an exothermic reaction. So it monitors the energy. Next slide. Our market is actually the grid storage market. We're not looking at entering the EV market. And the reason for the grid storage market, if you look at this animation, we generally generate power during the day with the solar panels and so on. But what a lot of people don't realize that during the day, Germany discharges about $2 billion worth of renewable energy to the ground. California, something like 3 billion. And the reason for that is there's an excess power during the day. Now, the future of EVs, as more and more EVs come online, they're going to draw a lot of power during the day when they charge up. And so you actually need grid storage batteries. So a grid storage batteries, it's just batteries that sit on the grid. And essentially during the day when the sun's out, they charge these batteries. And at night, they discharge the batteries. And essentially, it's an energy shifting exercise. The next slide. The grid is growing at 28% year on year. And even Elon Musk has said the future of the battery industry, their battery production, will be the grid storage market. Okay, so let's look at one of these batteries being produced in essentially a pilot plant that has been built by the Fraunhofer Institute. We are producing these batteries now as a prototype. Here you can see the alumina being mixed. This forms the ceramic bit of the battery. The alumina plus any extra additives goes through a spray dryer, and these are then sintered in these kilns. So the ceramic piece is the solid state. Once this is formed, it's checked for quality. As you can see, you can pick up any defects by just using light. And here you can see the ceramic piece being assembled in the metal canister. The next part of the process is to add the salt and the nickel metal powder, which forms the internal part of the battery. And then the next step is to then start welding these batteries together. As you can see, the welding process here, and some of these batteries undergoing some tests under different temperature conditions. So our joint venture is, we own 75% of the joint venture. We are building a 100 megawatt battery plant in Saxony, Germany. Next slide. So as you can imagine, we are producing these cells at 1 every 45 seconds from scratch. So you can imagine that there will be a lot of automation and robotics, and Germany is a great country for that. There is a very strong automotive industry with a lot of automation and robotics. Next slide. Our first product is this 60 kilowatt pack, 100 amps, 600 volts, and essentially you can see the cross section of it. There are 5 shelves of these 240 cells. What you notice is that there's no cooling fans on these batteries. They can sit in the snow and they can sit in the desert, and they can operate very well without any of those cooling fans and so on. These 60 kilowatt batteries will then go into our basic product with this, which is a 1 megawatt battery pack. Next slide. This 1 megawatt battery pack has 18 of these 60 kilowatt packs. The whole idea of it is they can be delivered onto site without installation. You can drop it on the deck. It's a plug and play scenario, and immediately within 5 minutes, you've got 1 megawatt of battery storage connected to your grid. And this is really the key to the grid storage market, where energy is being provided, produced by these solar panels and so on. So essentially, that's our business model.
Thanks, Iggy. Great presentation. Number of questions have come through. Just in relation to the joint venture, I understand. Well, it's understood in relation to the project that's being built in Saxony. Does that cover everything from the joint venture, from the site to the pilot to everything, or is that multiple joint ventures?
No, that's one joint venture. We own now the technology, worldwide technology. We have the exclusive rights, so the patents that Fraunhofer have come under the joint venture. So the future is that we would then look at building gigafactories after this 100 megawatts. So the joint venture owns all the technology. No one has the right to license it without us.
And take us back to the start of the journey. Clearly, I remember even you talking to me about this project many years ago, and at the time it did seem like quite an adventure and something that certainly to aspire to, but well and truly ahead of your time. The question here is when did the journey start, and what triggered the decision for you to focus in this area?
Yeah, so a lot of people have asked why the Fraunhofer Institute have teed up with an Australian company, and we've even asked them that question. Why haven't you teed up with a large German company like Siemens or BASF? And essentially, they said they just take so long to make decisions and to move. We wanted somebody that is entrepreneurial, that had a background in the alumina side, which we have, which is the ceramic bit, and also a background in batteries. Our team also came from the lithium battery industry. So essentially, that's how we started. And we recognize that the future of grid storage battery is going to be an area that is nascent at the moment, but potentially lots and lots of growth. And that's the sector we want to be in.
And what was the history of the battery tech? Was it always designed as a tool for grid storage?
Yeah, the technology is actually not new. It's in the 90s, these batteries are being produced for application like buses and so on. So they have been in circulation. So that's why we can say these batteries last beyond 15 years. What the Fraunhofer people did was to scale it up so that they can cater to the grid storage market. So these batteries are about 3 times larger than the 90s technology.
There's some questions here around status on a couple of things, obviously, that shareholders are waiting on. What's the current status of the 2 Seren Energy 60 kilowatt an hour prototype batteries, are they still being fabricated, or is fabrication complete and now being tested?
Yeah, they're right in the middle of fabrication. So within the next quarter, we'll have those prototypes up and running and just going through the tests. It doesn't really slow up what we're doing. We're finishing a definitive feasibility study. So within the next quarter, we will be announcing that. We are already in application for grants. We think that the funding of the project will be threefold, consisting of roughly a third of grants, maybe a third of debt, and so some equity. So we're already talking to various banks around Europe. And we're also looking at the permitting process as well. We want to get that underway. As you know, we've got the land, and really we want to keep pushing all these things. And so the prototype doesn't actually hold it back. The next important milestone is to get an offtake with one or two parties to purchase all the batteries we're going to make in the next 5 years.
That was partly my next question. Who buys these products, and at what stage are discussions at with potential customers?
Yeah, we've got interested customers. We're virtually looking at one or two to take all the batteries, and they are generally utility suppliers. So they produce electricity, and what they're doing is moving to renewable energy. So a particular one we're talking to are putting something like 8 gigawatts of renewable energy onto their grid, and they need batteries essentially. And they're not concerned about the type of batteries. They will use a combination of batteries, lithium-ion batteries, our batteries, or redox flow batteries. It doesn't really matter, but they need that energy storage so that they can shift the energy during the day to the nighttime.
Some good technical questions here. Is the battery efficiency market competitive?
Yeah, the battery efficiency is very close to lithium iron phosphate batteries. They take about 8 hours to charge during the day, and they can be discharged during the night for 8 hours. The maximum they can be discharged is 4 hours, but also they can be used as a power discharge. So nearly a quarter of the density energy of the battery could be discharged in 15 minutes. So that also is important for frequency modulation in these grid storage.
Do you see these type of batteries potentially reducing in size and overtaking lithium batteries in the future, or lithium-ion batteries? Sorry.
The battery is slightly heavier than the lithium-ion battery, and that's why grid storage is the ideal market. It doesn't, it doesn't matter that it's sitting there on the ground. So it's really the key market. And we didn't really want to compete in the EV sector. The EV sector is generally overcrowded, but we wanted a market that is nascent and has a lot of growth, and we can dominate that market early. And essentially, that's why we're just focusing on grid storage.
And do you have any competitors using similar technology?
No, not similar technology at all. There are other. I think you would see people on the news about sodium-ion batteries. Sodium-ion batteries are actually like lithium-ion batteries, but they're using sodium. That's a totally different chemistry to our batteries. The other type of batteries are sodium-sulfur batteries, which is a Japanese company called NGK, and also a different type of technology. Our batteries are much safer than the sodium-sulfur batteries.
Thanks, Iggy. Great presentation. Clearly generated a lot of interest. And as I said, one of two stocks that was much in demand from viewers of this webinar series to get you on. So we appreciate you coming on and telling the Altech story. Iggy, thanks for your time.
Thank you.